Welcome to Tompkins Robotics lab here in Orlando, Florida. What I want to first do is introduce what you're looking at so that you understand what all we're going to see in our lab today. This is our main demonstration sorter system. There's three fingers that the robots sort on. Beyond this system, there is another parcel sortation system, and it was a system that we designed for the U.S. Postal Service. And then yet beyond that is another small system for backroom sortation. What you can't see is a system off to your left that is for demonstrating our cross-belt robot. And those are the four systems that we're going to look at today, as well as some other things that we have in our lab, some supporting equipment for the robots. So to begin with, we want to show you the control system that is controlling the robots locally. This is an on-premise server that sits at every one of our sites, and it communicates to the robots wirelessly over a 900 megahertz frequency, and it operates in this box right here, this server stand. And as you look at this system, you see that there's three fingers, right? Well, we're going to go over to the control software. So Shane, why don't we jump over to that, and then we'll be able to see these exact same three fingers. So what you're looking at here is the robots as they are actually running right now. Obviously, the robots are the circles. The purple circles are robots that have an item already assigned to it, and it's en route to a destination to sort it. Green robots are available to return to an induction location to receive another item. White robots are operating normally, but they're a candidate to be recharged. This system will recharge the robots automatically, so when a robot reaches about 80% of full charge, the system will send that robot to a charge location. At the very top of the screen, these two orange locations are actually charge locations. The robots go there, they back into a charger and charge themselves. We'll show you in a few minutes that particular charge location. After 5 to 10 minutes, the robots come out and they continue operating. The robots that are entering the induction area, and when I say induction, that just means the location where we are putting an item onto the robot. You can see here that the robots enter these dark blue squares, which are queuing locations. They queue up there, and they come in, receive an item, so they turn purple. They go out, they go to their sort destination. A little bit lower on the left-hand side, you'll see two induction locations, two green squares side by side. We'll show you in a minute this side-by-side induction, which makes for a very, very high throughput induction rate. When the robots are en route to a destination, if any of them is carrying an item to a destination that's full, the robot will not go to that location. Instead, it'll go to one of these white locations, which are parking locations. It'll park there until the destination is cleared. So how do we know that the destination is blocked? Right now, I'm blocking some of these sort destinations. I'm doing it manually. The other way these could be blocked is through a photo eye at that location, which, if it's blocked by items overflowing that bin or that tote or that chute, then it will be blocked. Robots won't go to these locations. They'll take their item and they'll wait. As soon as the sort locations are cleared, then the robot will proceed to divert its items to those sort locations. The interface here has other features. Tells information about the robots themselves, every robot ID, status, its location on the grid, the voltage of that particular robot in millivolts, its current task, it's the sort destination that it's being assigned to, and a bunch of other information. We also provide a number of analytic screens and data for export into reports that we can generate out of this. The reporting would include information about every single induction, every single divert, every single robot. All of that data is being collected and logged, and we create reports out of that data. So this is our control software. And this is our induction station. Overhead, we're using 2 cameras, barcode scanning cameras. These happen to be Kients. We can use cameras by SICK, Cognex, anybody. Now there's 2 cameras because they're over 2 different locations, and this camera is associated with this robot, and the camera to the right is associated with this robot. So when an item gets scanned by this camera, our system looks up that item, understands which order we need that item for, and it sends the location of that order to this robot, telling this robot to go deliver it to that location. Same for this one with its overhead camera. We're going to show you some induction in a second, but we just want to show you the screen that the operators see. This is very simple. We try to design it such that someone with maybe 8th grade level education could use this because oftentimes the people that we have working in the warehouses don't have a high education level. They just need to be able to read this and induct items onto the robots. So you can see that the operator can either choose the hand scanner or the network scanner, which is the overhead scanners that I showed you, or they can manual enter items. So, okay. Well, why don't we go ahead and we'll show you inducting some items. Eric is putting some items onto the robots. They come from these red bins here, and these bins have been batch picked from the pick modules in the warehouse, and brought down here by conveyor, by cart, however they arrive. They're delivered to the induction location as batched items, and he's inducting these to be sorted to their orders. Each one of these robots coming through, I mentioned we have 2 induction locations. The robots can come through at a rate of about 750 per hour. A human can operate at about more than 1,000, 11 or even 1,200 units per hour. So that's the reason we want to have 2 robots always present for the operator, so that the operator is kept busy all the time, and that the robots are always there. Okay. We're demonstrating sorting quite a bit of apparel and typical e-commerce items. We also are able to sort round objects. Yeah, sure, let's sort that. So that is a bath ball, and even a round bath ball will stay in the tray all the way to its sort destination. We'll let you continue to watch a little bit of the induction happening there. And then we'll show you some other features of the system. Okay, what you're looking at now is an elevator. We found that it's very advantageous to be able to stack our systems up with multiple levels. And you can see that our system here is a 2-level system. Robots can sort on the top level, they can sort on the bottom level, but it would also be advantageous if we could have a robot move from the bottom level to the top level. Otherwise, we have to do a pre-sort prior to inducting the item. We have to sort top items to a top-level batch and bottom items to a bottom-level batch. With an elevator, we don't have to do that pre-sort. We can put an item onto a robot on the top level and it can make its way to the bottom level and vice versa. The other advantage of having the robots is that sometimes we have more orders for the top level, let's say, and so we need more robots on the top level. We can send more to the top level. Same for the bottom level when there's more orders for the bottom level. So it helps us to balance out the robots on the top level and on the bottom level. Moving on, this is the charge location that we showed you in the control server. Robots will pull into this charge location and charge on the charge heads. There's 4 charge heads, 2 for the top level and 2 for the bottom level. And there's none that need charging right now. But should their voltage drop below about 4.5 volts, the system would tell that robot to come over here and back in and to be charged. This whole charge cart operates on 120 volt, 30 amp circuit. So there's nothing special. We don't need any 3-phase. We don't need anything more than household power to be able to operate this system. The entire system is very light on your utility budget because of the low use of electricity. Okay. Next on the system is a type of chute that we've designed for store replenishment, in specific for shoe retailers. This is an accumulation lane, meaning that we're accumulating items for store replenishment. These would accumulate on this pencil roller, and then we would build a pallet at the end of this to be shipped to the stores. Now, the challenge about this is that all of these shoe boxes are unbanded, open shoe boxes with shoes in them. And typically sorters have a very difficult time with these because the shoebox lids could fall off very easily. But in our case, they stay on and they all get diverted successfully. Something that's very difficult for most sorters to do. Okay. And then our next type of chute is has been designed for fragile items. You'll notice that we have a very shallow transition piece of the chute so that items like a glass candle jar can come down and not be damaged. So it's easy to sort one candle jar because we could just put padding down here, but when you get 2 or more, they hit each other, and you want to make sure they don't crack each other. So this is a real candle jar, glass, and we're able to sort them without any cracking. Part of what enables us to do this sortation is that the robots themselves are able to adjust the tilt angle according to the product that's on them. So when an item is scanned, we look up that item in the item master, it may say that it is a category 3 handling characteristics. And so that might mean we should only tilt the tray at 30 degrees instead of 60 degrees. It might mean we should, the robot should turn slower or accelerate more slowly. These are all things that we can control based on the scan of that item. So very difficult for most sorters to do, but with a robotic sorter, we can actually adjust how we handle individual items based on the scan that we receive of the item's barcode. And a more typical type of chute that would be on our system are these black chutes here that are used for e-commerce orders. There's a couple different sizes of chutes here. There's 6 of them that are 4-foot long chute. We have 2 down at this end, which are only about 3 feet long. The length of the chute is really just a matter of what is your typical order size, how many items do you expect to accumulate in any given order. Once items are sorted to these chutes, then an operator is told that all of the items are present for that order. That order can be closed out, and these items can be taken out and packed for shipping. Now, what if the items that go to one order are very large and they're too big for this? Well, here we have in the sides of the chutes, we have a location for a photo eye. The photo eye looks across here, and at this point in the chute, if there are items higher than that, then the system knows that this chute is full. Robots won't deliver items to this chute. They'll go and wait until somebody comes and packs it down or clears it out. So we are able to use photo eyes to indicate that. We have quite a variety of products that we're able to sort. Some heavy items, such as motor oil. We have here a can of hairspray or something. There's some motor oil that we're able to sort. So quite a variety of product all works with this particular type of chute. And next in line are a couple of Gaylord boxes that we're sorting parcels to. Now, we didn't have to make any change over in our system to change the system from sorting units to parcels. In fact, we can sort parcels and we can sort individual items belonging to orders. We can sort those at the same time on the same system. Now, you'll notice 2 robots dumped into the same box side by side. And we actually, each one of these Gaylord boxes is 2 sort destinations wide. So what we do is we sort some items to the back of the box, some items towards the front of the box, and that way it keeps the total load in that Gaylord balanced front and back. We have quite a number of ways to induct items onto the robots. One of them is to use an A-frame dispenser. Now, if you're familiar with A-frame dispensers, they are typically used to sort items to a tote that's on a on a conveyor. In our situation, we're sorting directly onto the robot. So as you can see, the robot passes by the A-frame, and the A-frame dispenses items into it as it's passing by. The robot maintains a speed of exactly 1.5 meters a second as it's passing the A-frame, so that each of the 16 channels in the A-frame shoots a product out at the exact right time to hit the center of the robot. And with amazing accuracy, we always get the items into the tray of the robot. So you'll notice that some of these passes, the robot is receiving 3 or 4 items at once. That could be a complete order, or it may be a part of an order, and we supplement that order through some other induction manual or whatnot to complete the order. But this is able to do very rapid dispensing of the product. Okay. Okay. We also want to show you under the tables that all of our platforms are on wheels. Everything's on wheels. You can see the tote carts as well. Those are on wheels. The charge cart that you saw earlier was on wheels, the elevator, everything. And that means that we can move the system very easily. It's very mobile. It's portable. And in fact, because it's on wheels, we're not required by fire code to have fire suppression under the tables. They're just tables. And in fact, we have 5 systems installed in California, and we've never been required to pull any sort of patent, any sort of license to meet fire code. We've never had to install fire suppression. Okay, let's go to the, we promised we'd show you the sorting cross belt robot. And that's what you're seeing. Eric is inducting some items onto the crossbelt robot. This robot can carry a load of 66 pounds, so quite a bit more than our others. And the reason we developed a crossbelt robot is that from time to time you may have very heavy parcels that are awkward, and you may be concerned that they would tumble if you put them on a tilt tray and tilted them into a sort location. But in this case, they slide off sideways and they don't tumble as they're diverted. You'll see that the robot has 2 belts on it. So currently these belts are operating in tandem, but in the future we'll be able to, those belts will operate independently, so we can sort one item to one location and another item to a separate location. Okay, we mentioned that the sort locations all have photo eyes, or they can be fitted with photo eyes. And we want to show you that here at some of the Gaylord box locations that are on our parcel sorting system. So here's a photo eye. You can see the light shining. If an item blocks that, then this location becomes blocked in the system, so a robot will not sort to this destination. Also, on every finger, we have a stack light, and the stack light comes on when any one of many sort destinations on the finger becomes blocked. It just indicates to an operator there's something that needs to be serviced in this finger, right? So we're going to just demonstrate this now. Let's say this becomes blocked, okay? Light goes on. Eric is going to put a product on a robot that's destined. I happen to know this item is destined for this location. So it's going to come down here, but because this location is blocked, that robot's not going to stop and divert the item. It's going to go to a parking location. So this location here is a parking location, and it'll wait here until someone comes along and clears it out, and then indicates that that is now available. So the robot then returns to that sort location to sort the item. And there it goes, sorting to that item, to that location. So you can see there that Eric is putting item parcels onto the parcel sorter, sorting to their shipping destinations. One of the a few of the unique features of the system are around the induction, where we're actually able to capture the item's weight and dimensions as well as its barcode while it's at induction. So this square right here is a scale. On the bottom side of it is the load cell. Robot coming in, we weigh the robot is okay, 42. We put an item on, we capture 46, so we calculate the weight that way. We're also able to catch the dimensions. So this camera, this view of the dimensioning camera, the blue square that you see, and it's happening pretty quickly, that is capturing the dimension. So you can see these overhead cameras with the blue lights. Those are the those are the barcode cameras. They capture the barcode. Now, on this one over here, a little bit to the right of it is a black box. That's the dimensioning camera, all mounted to this gantry overhead, and it takes care of scanning the robots as they pass through. And the last system that we wanted to show you is a backroom sorter. So this system is relatively small, 3 tables. It only has 2 lanes for the robots. You see the robots all queued up in 2 lanes. So it works basically as a racetrack. The robots come down and divert to whichever location their item belongs to, and then they return for more items. Now this backroom sorter is intended to be used in the backroom of perhaps a big box retailer or a grocer, where items are batch picked from the front of the store, brought to the back room, and then they need to be sorted to their orders. Say those might be buy online, pick up in store orders, or for shipment, and so they get sorted to their orders using our system. Now we can sort. Perhaps we can do some items in trays. You'll see what Eric is doing now is putting an item in a tray that gets transferred to the chute. So what this tray does is it protects the item when it's sorted. So for example, a bottle of olive oil, we may not want to send this olive oil by itself down the chute, so we put it in a tray and it gets sorted that way. So using the trays, there's really nothing we can't sort. We can sort anything that you would find in a grocery store. We could even use these trays for fresh produce, for breakables such as chips, and we can sort anything you'd see in a grocery store. Okay. All right, one last thing we wanted to show. So we said that the robots know where they are by reading the location and the orientation of the robot in its location, and that's because of these tiles. So here is an example. These tiles we simply lay down on a new system, and they're very easy to install. And there we go. And that's the surface that the robots run on. So, but with that, I think we've covered everything that we have out here in the lab that we wanted to show you for today. Continue to ask questions and appreciate your time. Thanks.